Alright guys, so now we've got a good understanding of how a class and an object works in object-oriented philosophy, and in Java we saw what the syntax is like. Now let's move on, and I'm going to talk about another core principle of object-oriented programming, that is polymorphism. And polymorphism is like one face, many forms. And the first way to implement polymorphism in Java is through the concept of method overloading, right? So I'll just walk you through a real world example, and then you'll understand how method overloading is a handy feature. So I'm just going to create a new project this time because we've already got a few things working in the previous project. I don't want things to look like messy, so I'll just create a new project here for you. Let's say a Java project and hit next, and let's just call it moving ahead, right? And use the execution environment GRE15, that's fine. Next, and I'll just not need this module info.java file, and hit finish. So Eclipse, my friend, is going to create the folder for me, the project for me, the folder behind the scenes for me. It's going to call it moving ahead with the default Eclipse structure, right? So I'll just for now close all of these other files, right? And in this project, I'll just create a new class. Now, moving ahead, and then let's again put in the package name to com.valid.training, and the name as, let's call it overloading demo, because we are demonstrating method overloading in Java. The first way, the first mechanism to implement method overloading, polymorphism in Java, right? Okay. So consider an example where I have a requirement from my client or from someone that says I want to create an API where I would be given two numbers and my method should throw back the addition of those two numbers. So how would I go about that? I'll just create a simple class here. I can call it calculate addition. Again, I will repeat it many times again and again. That is putting in relevant names, better readable names, following industry standard mechanisms, following the camel case terminology of naming identifiers. These things, all of them contribute to you being considered a good developer, right? So class calculate addition, because that's what we're going to do in this class. And then I'll say I have a method which returns a type of int. I'll just call it add, or you can just call it add numbers, right? Just call it appropriately add numbers, and which takes two parameters of type int. I'll say int first number, int second number. Right, and which just returns the addition of these two numbers, guys. I'll say first number plus second number. Off you go. That's a clean looking code there, right? Does what it is expected to do. And you know that if I want to call this, obviously I have to call it from the main method, right? And this class is called overloading demo, and it has the main method. This is where the execution starts of this program, right? So I'll just create a new object of this class. I'll just say calculate addition. I'll just call it ref, the reference variable, and then new calculate addition, and we'll just call the method, that is add numbers. Pass the numbers statically, that is hard-coded values, or from runtime. And you know, from the previous session, I just discussed about how do you take user input from runtime in Java. That is, we did it through the scanner class. But for now, because the focus is something else, I'll just make it a little quick. I'll just pass in two numbers statically. But you know how you would do it through runtime as well, right? So I'll say, for example, 56 and 17. That is what I want to do. And I'll take the result of these, the addition, in a variable called result, and then print it out for you. I'll say addition of numbers is, and I'll just print it out, that is result. Okay, let's see if this works. Hit save and run, and it does, right? Unexpected lines, because obviously 56 plus 17 is 73. All right, now let's say the requirement changed a little. The guy came to me again and said that now I want you to add three numbers, but the functionality of adding two numbers should be there as well. So what would you do as a developer? You'll just go on and declare another method, that is int. Again, I'll just call it add three numbers. for example, and then I'll just this time pass in 3 parameters. I'll call them int second and int third appropriately. And what it would do is return the addition of these three numbers. Nice. First num plus second number plus third number, right? And you know that in order to call this method now, I would just comment this and copy paste this for you, and I'll just call add three numbers for this method to be called, which takes 3 arguments, guys, right? See, same I run this, you should now get the addition of 3 numbers, that is 56 plus 17 plus 1, right? It says we have an error here. Let's see what we've got wrong here. Result ref.add 3 numbers. Okay, let's see what the errors are. Okay, it says unresolved compilation problems. Insert variable declarators to complete local variable declaration. Let's see where we have gone wrong here. It said int 3 numbers, first number, int second number, and int third number. And then I'm just saying return first number plus second number plus third number. So what is wrong here? Let's run it again. It says overloading.demo, line number 12. Okay, sorry. Yeah, I put in a R mistakenly, guys. Let's say we run this, and this time we got 74, which is the addition of 56 plus 17 plus 1. After some time, this guy came to me again and said that I want you to develop a logic where there should be a platform, an API, which adds 2 numbers, throws back the result. Another one that takes 3 numbers, throws back the result, and another one that takes 4 numbers. So what would you do? I'll just copy paste this as a developer and call this appropriately add 4 numbers, and then pass in 4 parameters to this. All right. Just call it 4th number, and then return back the result of the 4 numbers. And you know, in order for you to call this, you have to call add 4 numbers, right? Pass in 4 different numbers. Right. Save and run this. We got the result on expected lines, desired output. So after some time, yet this guy comes back to me and says, now I want you to develop a functionality for me where we have the flexibility to add 5 numbers as well. So you could have just created another method called it add 5 numbers, passed in 5 parameters, and returned the addition of those 5 numbers. But after some time, you realize all you're doing in all these 4 or 5 or 6 methods is you're essentially doing the same job. And that is, you're just adding numbers. The only thing that changes is the number of parameters, the number of the values, right? So that is when polymorphism comes to the rescue. And that is, you don't need to, when you in the same class with multiple methods, you're essentially doing the same job. You don't need to call these methods ugly or different, right? Because you're just adding, guys. I can just call all of them the same, right? And that is the concept of method overloading. And that tells you when in the same class you have multiple methods with the same name, that is called method overloading, right? And this is special because otherwise Java doesn't allow you to redeclare identifiers. But here it does in a special scenario, the special scenario of method overloading, where it says that you can now have multiple methods with the same name in the same class. But, and there's a big part there, but the parameters have to be different. And how? Either their type or their number or their sequence has to be different. And then I can just do this, see? Because essentially in all these 3 methods, I'm doing the same job, guys. I'm just adding numbers. But what differs is the number of parameters I'm adding. In the first one, I'm adding 2. In the second one, 3. In the third one, 4 parameters. And even in the fourth one, if I develop it, the 5 arguments. But you're seeing that the flexibility to name them the same. As I told you, polymorphism, as it says, one face, many forms. The face to the outside world is just add numbers, but many forms, guys, different forms. And that is overloading, the first way to implement polymorphism in Java. But remember the rule. The rule says you can now have multiple methods in the same class with the same name, but the parameters have to be different, either their type or their number or their sequence. And here in these three methods, I have the same name, but the parameters are different. How? Their number is different. Here I have just two parameters, here 3 and here 4. And when I call add numbers, there's just one method now. And I pass in 4 arguments, you know which one of these would be called, that is the last one. And when I just pass in 2, you know which one would be called, that is this one. Right? That is the concept of overloading, guys. One face, many forms.